Today we'll be looking at the law of cosines, which is similar to the law of sines. Both allow us to solve angle measures and side lengths in triangles, except the law of sines is a bit restrictive in that I can only use it when I have an angle measure and its opposite side length. For law of cosines, this solves that problem because it allows us to use this when I have all three sides and no angle measures, or two sides and the included angle. So let's take a look at what the law of cosines is. I've got two forms. One is the standard form. Here are three variations of this, just changing based on whether I'm solving for A, B, or C. And then the alternative form, this is just the standard form, but things are mixed around a bit. Cosine of A equals B squared plus C squared minus A squared over 2BC. So you're just solving for your cosine of A, and then once you have that, you're going to do the cosine inverse. Now, the standard form is used when you're looking for a missing side length and you have all of this other information. You've got B and you've got C, these two side lengths, and you've got the angle A, but you don't have the side length of A. The alternative form is used when you're looking for an angle measure. So you don't know angle A, but you do have all three sides, B, C, and A. So we're going to look at a couple of examples. The first is this one here. Find the missing angles in the triangle below. So I have all three side lengths. I've got A is 8 feet, B is 19 feet, and C is 14 feet. Now note, it is best, if possible, to find the angle opposite of the longest side length first. So the longest side is 19, that's B. So what I'm going to do is I'm going to find angle B right here. So going back to my law of cosines, if I'm looking for angle B, I'm going to use the alternative form because that helps me find an angle, and I'm going to use the one that has cosine of B equals. So let's begin there. The cosine of B is equal to A squared plus C squared minus B squared. This is over 2AC. And now we can fill in what we know. So the cosine of B, this is going to be equal to A is 8. So this will be 8 squared plus C is 14. So we got 14 squared minus B is 19. So 19 squared here. This is over 2 times A again is 8. And C is 14. All right, I have to be really careful in my calculator. I'm just going to do the top part first. So we'll do 8 squared, like so, and then plus 14 squared, and then minus 19 squared. It's important to use these parentheses because if you have this minus sign with the 19, or if it treats it as a negative 19 squared, then times this 14 squared, you're going to get all kind of messed up. So make sure to use your parentheses here. So we negative 101. Now we're going to divide this by 2 times 8 times 14. So let's find what that is first. 2 times 8 times 14 is 224. So this top part is negative 101. The bottom part is 224. So negative 101 divided by 224 is negative 0.45. 451 will go. So the cosine of B is equal to negative 0.451. But b is stuck inside of this cosine function. So to get it out, we're going to do the cosine inverse. But I have to do that to both sides. What's going to happen is the cosine inverse and the cosine undo each other, leaving just b. So b is going to be equal to, we go cosine inverse of that is 116.8. So b is equal to 116.8 degrees. Then I can use law of sines because now I've got an angle and its opposite side length. So if you find law of sines easier to work with than law of cosines, once you've used this once you've used law of cosines once, then you're allowed to use law of sines to find another angle measure. So we can do, for example, the cosine, or no, not cosine, the sine of a over little a is equal to the sine of b over little b. So we can fill in what we know. I don't have angle A here, so this will be the sine of A over 8 is equal to the sine of, we just found B is 116.8 over 19. So we'll cross multiply. So when we cross multiply, we'll get 19 times the sine of A this is equal to 8 times the sine of 116.8. And then we'll divide both sides by 19. Okay, the sine of A is going to be equal to, let's find this, 8 times the sine of 116.8. We'll be dividing that by 19. So the sine of A is 0.3758. And just like we did over here for the cosine of B, where B was stuck inside of that cosine, A is stuck inside of this sine, so we are going to do the sine inverse. All right, doing that to both sides leaves A is equal to sine inverse of this is about 22.1. So say 22.1 degrees. Lastly, to find C, I could use law of cosines, I could use law of sines, or now that I've got two of the angles, I know I can do 180 degrees minus these two. Which is 41.1. All right, let's highlight our answers here. We have found that B is 116.8 degrees, A is 22.1 degrees, and C is 41.1 degrees. Let's look at an application that we might use law of cosines in. The pitcher's mound of a softball field is 43 feet from home plate. So I've got a picture over here. We've got home plate at the bottom, first base, second base, third base, and the pitcher's mound is sort of in the middle, but not exactly in the middle. So it is 43 feet from home plate. I've drawn a line here, and then 43 feet between H for home and P, the pitcher's mound. The distance between the bases is 60 feet. So from home to first plate is going to be 60 feet. From first plate to second, it's going to be 60. From second to third, 60. And then from third to back to home is another 60. And then note here, the pitcher's mound is not halfway between home plate and second base. So it is a little bit closer to, looks like a little bit closer to second than it is from home. So how far is the pitcher's mound from first base? Well, based on the information that I'm given, I know that this length is 43 feet and this length is 60 feet. The angle here is 45 degrees because this is a straight vertical line here, which separates this 90 degree, because this is a square, in exactly two. So this is going to be 45 degrees because I've got another 45 degrees over here. So let's use law of cosines. I've got two sides and the included angle. Now, I'm not using A, B, and C here. I'm using H, P, and F, but I can easily translate the law of cosines to use these letters. This is going to be H squared, because that is the length I'm looking for. This is equal to, the other two sides are P and F. So P squared plus F squared minus 2PF times the cosine of H. Let's plug some things in. H squared is equal to, P is 60, so this will be 60 squared plus F is 43, so we got 43 squared here, minus 2 times 60 times 43, and this is times the cosine of H is 45 degrees. Let's plug all of that into a calculator. I've got 60 squared plus 43 squared minus 2 times 60 times 43 and then times the cosine of 45 degrees. Okay, so I've got 1,800.329. H squared is equal to 1,800.329. And because this is H squared, and I'm solving for H, we're going to take the square root of both sides. So H is equal to square root of this is roughly 42.43. So H is 42.43 feet. That is how far it is from the pitcher's mound to first base.